Good morning, good evening, whenever you are finding this video. We're going to talk about chapter 9.2. I understand it has been less than ideal to have me not in the classroom teaching this, but I hope this is at least some kind of replacement for me actually being there. Alright, 9.2. We're talking about the Pythagorean Theorem and some actually additional things with it. So not just the theorem. I know most of you know the theorem and you're very good at it, but I just want to make sure we are, there's not just the stuff we did in middle school, there's a little bit more on top of it. This should be a quicker video, hopefully, but we'll see how long it takes. Alright, let's start just with the Pythagorean Theorem. I know you know it, but I'm going to write it out again. It is a squared plus b squared equals c squared. This is a really important idea that you will use again and again in your mathematical journey. Couple things about it. Number one, it is only for right triangles. So it is not something we can use for every triangle we run into, but it is only for right triangles. That being said, hopefully you remember like these are the legs of the triangle. This is what's called the hypotenuse. So depending on what I have and what I don't have, I can solve for that. So I have a squared and b squared and c squared. Let's do a quick example. If I had some kind of right triangle, I'll do it this orientation, it doesn't really matter, where this is 6 and this is 7, I can find the amount of the hypotenuse. Let me grab my calculator. I can find the amount of the hypotenuse like this. It would be, call it just c. So 7 squared plus 6 squared equals c squared. That'd be 49 plus 36. And then we're going to square root that. 49 plus 36. 85. I know 81 makes 9. So it's going to be something above 9. And we want... Sorry, that's not right. That should just be c squared. So c squared is 85. So c would be something like 9.2. Something like 9.2. Not exactly, but we cut decimals off. But in this class, one decimal place is good. So that's a very beginning idea to a Pythagorean theorem. We have a squared and b squared is c squared, where if I have these two, I'm going to plug in for them, and I'm finding the hypotenuse. Yeah, that is nothing new. That's stuff we've even done this year in class. And what you should be able to do is solve any of this. Be sure if you're given your hypotenuse, you can solve for a leg. Make sure you can do this kind of stuff all the time. Keep this in your back pocket. Know that it's only for right triangles. Well, we can actually do what's called the converse of this, which is to take this idea and work backwards. So, for example, last semester, I think, we had rules for making a triangle. So let's say, for example, we have a triangle with these 3 sides. They're length 3, length 4, and length 5. They can be anything you can imagine. They could be centimeters or feet or inches or whatever you want to think about it. So these are the triangle lengths we have. We can actually show and know that this is a right triangle if our rule works. So we can use it the other direction as well. If you remember before we talked about this, we talked about how 3 and 4 have to be bigger than 5, 4 and 5 have to be bigger than 3. Whenever two of the sides came together, they had to team up and be bigger than the other one. So those rules still work, and if this works with my three sides, then I know it's actually a right triangle. So I'll plug in 3 here, 4 here, and 5 here. Quick note, why did I put the 5 over here? It's because it's the biggest. The biggest number has to go over there. Because remember, a right triangle has a hypotenuse, and the hypotenuse is the c squared. And sure enough, this works out. This is something called a Pythagorean triple. So Pythagorean triple is 3 numbers, 3 whole numbers that come together to make a squared plus b squared c squared. Makes sense. So that works. That is a valid right triangle. We can use the Pythagorean theorem to also show this is a right triangle. We can also use it to show it's not a right triangle. So if I used a different set of 3 numbers, let's say the numbers 5, 12, and 15. So if I took those 3 numbers and I tried to put them in Pythagorean theorem, they're not going to work out. 5 squared plus 12 squared equals 15 squared. I'll put a question mark because we're not sure if it equals. I'm going to tell you now, it doesn't work out. So that's 25 plus 144. 15 squared is 225. 144 plus 25. And so 169 is not equal to 225. There you go. So I could say this is not a right triangle. Just by using the Pythagorean theorem. I don't have to actually have a physical triangle or know any of the angles to know that something is or is not a right triangle. All I have to do is use the Pythagorean theorem and see if the rule fits. If I can plug in each of these sides to a squared plus b squared equals c squared, then I can know if it is a right triangle or not. But what about that? Can we even go further? The answer is yes. We can use even more to know about this. So let me break down this idea. I'm going to divide this paper into 3. I can talk about, let's do, I'll write this 3 times. Hopefully you're following along and writing your own notes in your notebook. That way, in the event of a notes check or something, or even doing homework in class, you are prepared to have all that stuff. All right, I'm going to use 3 colors. Number 1, we're just going to start with equals. So that's our Pythagorean theorem that we've talked about. Let's talk about is greater than, and let's talk about less than. So we actually can know exactly what kind of triangle we have, a right triangle, an obtuse triangle, or an acute triangle, based on our results for taking our 3 sides. Once again, last semester we took the sides and saw if it could make a triangle. So sometimes we were given a group of sides that actually don't work, like 5 and 2 and 10. Those sides can't all come together to make a triangle. So let's talk about how we know what kind of triangle it can be. Let's start with equals. We just talked about that. This is exactly the Pythagorean theorem. right triangles. Some examples. We have things like we did last time 3, 4, and 5, or 5, 12, and 13 actually. So we were really close on that one. Trying to think of other Pythagorean triples. We can double this, for example, 6, 8, and 10, and on and on and on. So anything the Pythagorean theorem works with, we can know that's the right triangle. So we just talked about, it's like our test to see whether it is or not. And all of these, you're plugging in for numbers. So let's talk about this case, when a squared plus b squared is greater than c squared. What this looks like, oh, I need blue. What this looks like is something like this. I'm going to come up with the answer before I do this. Great. Great. All right, let's say we have the triangle 7, 8, and 10. 7, 8, and 10. Now, we know that's a triangle. We know that works because 7 plus 8 is bigger than 10. That was from last semester. But we know it's also not a right triangle. Is something 10 squared. Now that'd be 49 plus 64 something 100. So 49 plus 64 is going to be 113. And that is bigger than 100. We know if it matched, that's going to be a right triangle, but if this is true, it is actually an acute triangle. It is an acute triangle. How this works, the way I memorize it, is if the greater than symbol is pointing at the C, then it is acute with the C. So there's a C, it's kind of pointing, if you see up here, it's pointing at the C, and then acute has a C in it as well. If your a squared plus b squared is greater than c squared, it's acute. I'm sure you can figure out where this is going to go. So let me think of another one. Okay. No, we don't want that one actually. How about 10, 11, and 16? Okay. 10, 11, and 16. Once again, everything has to pass our initial test of is it a triangle or not. That is what we're doing here and last semester. So 10, 11, 16. 16 is going to be my C because it's the biggest number. 10 squared plus 11 squared, something 16 squared. It could be greater than, less than. It's going to be less than. We know that because of this example, but we're just going to pretend we don't know that. So that is 100 plus 121. 16 squared is 256. So that is 221. 256, well, that's less than. 221 is less than 256. So if it is pointing at the A and B, it is going to be obtuse. If you want to know the Mr. Goodrow way of memorization, to put that in your brain forever, well, it's pointing at the A and the B, so you could think of it kind of like obtuse. I'm not sure. I'm just trying to help you any way I can. So you have three options. If you're given a triangle, it could either be a right triangle, it could be an acute triangle, or an obtuse triangle. And instead of having to graph it and trying to measure it out exactly, we have a very simple method to do this. We could take each of our things, plug them in, and then square a squared plus b squared, and then square c squared, and then compare them. So if we get down here and we see, oh, it looks like this is greater than this, we know we have an acute triangle. If this is less than this, we know we have an obtuse triangle. So let's do one more example all together. Once again, the other part of this lesson is just the Pythagorean Theorem. Make sure you are very much okay with that. Make sure you practice that. You'll have some time to practice it in class. Yeah. So let's come up with some numbers and see how they fare. How about 7, 10, and 13? 7, 10, and 13. We're going to classify this triangle if we can. Now, first thing we have to think about, is it even a triangle? That is still on the table for it not being a triangle. And it is. This works out because every combination of sides is going to be bigger than the third side. So these two are bigger than this, and then obviously every other one is going to match as well. So, yes, 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 it is a triangle. Now we have to figure out what kind. So, this first test in orange, which is basically, is it a triangle or not? So, to classify this, I'm going to square 7 and 10. And then I don't know what that's going to be because I haven't done it, and I'm going to square 13. So, this is going to be an equals, a greater than, or a less than. It has to be one of those two. 49, 100, 169. Well, we have 49, 100, 169, and hopefully you can see here, it is 149 is less than 169. Okay? Well, what am I doing? I am pointing at this side over here. If we go all the way back in time, we remember this was our a squared plus b squared side. What is it when it's pointing at the a and the b? It is obtuse. That's my way to remember it. Obtuse. Obtuse triangle because it's pointing at those. Pythagorean theorem does not work, but this sort of hybrid of it, where we have kind of three different options with greater than, less than, or equal to. This is like a real Pythagorean theorem. If that works, it's a right triangle, and we're going to be able to do so much more with it later on in the chapter, but we can still classify it even if it doesn't work. So if it's bigger, it's going to be acute, and if it's smaller, it is going to be obtuse. Great, I hope this helped. I hope you took good notes. If you missed something, you can always go back, pause, take more notes, and there'll be practice problems available for you to try out. Thank you very much.